So it needs a little background about differential amplifier. So this differential amplifier is symmetric like human face. Your face is symmetric. If I cut your face into two pieces, the left half and right half will be similar. So your differential amplifier, if you cut it, it's similar. So one of the advantages of differential amplifier, you don't have the ground which is going to the output. Your input ground is not carried to the output. If you take a normal amplifier, at the input side you have one common point. That point will be continuing till the output. So your input terminal and output terminal are connected in a normal amplifier, but here the input ground is not going to the output. But you need a split power supply, or you need two batteries. This we call plus VCC, this is minus VCC. Midpoint I am connecting, I am grounding, so this is 12, 0, minus 12. In your lab you have a power supply which gives you 12, 0, minus 12. So for your op amp you have to give that supply. So this is plus 12, this is minus 12, and this ground is not anywhere in the output. So your output you are taking between the two collectors. So if you think that this looks like a monkey, if this circuit looks like a monkey with two hands being the two sources, then this looks like the tail of that monkey. The bottom resistor is the tail, and the current through this is called tail current. The tail current is this point. If I do grounding, if this point is grounded, then if I take this PN junction to be a closed switch, then this point is ground, or from this side this point is ground. So if it is ground, it is 0 volts, 0 minus of minus 12, that divided by resistance will give you this current. Every time if you are not happy to draw that resistor and not happy to calculate the current, you can just put, you can say that the current is IT. That is what we have shown here. So every time I may not be happy to draw that, so I can just say that that branch carries a constant current. Potential at this point is 0. Potential at this point was minus VEE. So a current flows from 0 to minus 12 because 0 is higher than minus 12. Current flows from high potential to low potential. So your tail current will be flowing from 0 to minus 12. So the current IT is called the tail current. So some of the textbooks, instead of showing that resistor and minus VEE, they will show a current sink. I think you know the difference between current source and current sink. Current source, the arrow will be looking up. Current sink, the arrow will be looking down. Your generator you represent as a current source. It supplies constant current. Or a PV cell, photovoltaic cell supplies constant current, so you represent it as a constant current source. But here you have a load which always draws constant current, so you represent it as a current sink. Now I am trying to explain what is non-inverting input and what is inverting input. You are going to use the terminal inverting input and non-inverting input. So for this amplifier, this terminal plus means non-inverting input. That means if I get a signal, input signal here, I will get similar signal at the output without any inversion. Without any inversion. So let us see how we get that. This one you are giving this potential here. At the collector you will have 180 degrees phase opposition. Then this signal comes here, and this looks like a common base amplifier. This looks like a common emitter amplifier. Emitter is grounded, so this is a common emitter amplifier. Here base is grounded. Because base is grounded, this is common base amplifier. So I get this signal here, then common base will not give me any shift. I will get a similar signal here. Now I want Vout. Vout is VA minus VB. Vout is VA minus VB. VA plus of minus VB. This is VA, this is VB, this is minus VB. If I add VA and minus VB, positive and positive, more positive, and negative, more negative. So in an op amp you have two terminals, namely plus and minus. I am trying to explain what happens internally when voltage is given to plus and minus is grounded. So minus is grounded, this terminal is minus, that is grounded. I am giving voltage to plus, I am getting an amplified voltage which is in phase with the input voltage. That's why it is called non-inverting input. Suppose if I give the input here and ground this terminal, then my output is inverted. So now this is acting as a common emitter amplifier. In a common emitter amplifier, I have a phase shift, 180 degrees phase shift between output and input. And this is a common base amplifier because base is grounded, so this signal comes here and this appears here. Now Vout is VA minus VB, this is VA and this is VB. So you negate this signal, then minus and minus, negative and negative more negative, then positive and positive more positive. So if I give input here and ground the other terminal, I am getting an output which is inverted. So this is called non-inverting terminal, and the upper one is called inverting terminal. I shall repeat again. This is non-inverting input. Other terminal you have grounded. So this acts as common emitter amplifier, this acts as common base amplifier. In a common emitter amplifier, between input and output there is a phase shift of 180 degrees. So this is VB. So this signal comes here, and between this and this you will have no phase shift, because in a common base amplifier there is no phase shift between input and output. Input I am giving to the emitter, output I am taking from the collector. So this is my signal here. Now VA minus VB, VA is this, VB is this, minus VB is this. So I have to add minus VB and VA. If I add VA and minus VB, I will get a large positive signal. So if you ground this terminal and give input here, you get an amplified signal, but that is in phase with the input. Whereas if you give input here and ground this signal, you will get an amplified signal. So this is called non-inverting terminal, and the left hand side, the input side, is called this is called inverting terminal, this is called non-inverting terminal. Because if you simply see this triangle and what is plus, what is minus, you should not dream. This entire subject is in the triangle only, so you should understand about the triangle. So if you, so we got this one as non-inverting, other one as inverting terminal. You can take input here separately, you can give this, so this is two inputs type. This is differential type, and bring this wire here, give the input here, take the output, that is differential. This is common mode. I am tying up both the wires. If you tie up both the wires, that is called common mode. On the day of marriage, they tie up the clothes of bride and bridegroom, so that they will not run away on that day. And the ayah there expects them to chant common mantra. He will tell some mantra, mama. So both of them should say mama. So that is common mode. Common mode means tying up clothes of wife and husband. So you are tying up the wires called non-inverting input and inverting input. Same signal will be given. Such thing is common mode type. And here if you take both the signals and give input here, this is differential. Only one terminal if you take, this is single-ended output. This is not popular. You are not using this wire. You are using only this wire. This is single-ended output. So these are different terminologies. So inside op-amp you have a common drain amplifier, then you have a differential amplifier, and then you have a buffer. You should not think that op-amp is a devil. Op-amp is not a devil. If you want to understand op-amp, you need to have background of your electronic circuits. So in electronic circuits, you have studied common drain amplifier, you have studied differential amplifier, you have studied buffer. So if you combine these three, you will get op-amp. Maybe two differential amplifiers, may not be just one differential amplifier. You may have two differential amplifiers, because if you cascade, the gain will increase. Whenever you cascade, the gain will be increasing. So now we have to see each block. Common drain amplifier is buffer. You have studied in electronics, you can use common collector amplifier or common drain amplifier. So in a common collector amplifier or common drain amplifier, input voltage is equal to output voltage, but output current is much greater than the input. Your output current is much higher than the input current. So This is just amplifying the current. This is amplifying the voltage, and finally you have a buffer. So even if you make some mistake at the output side, nothing will happen to this. Buffer protects rest of the circuit. So now we will see each one separately. So this is called current mirror. Suppose if this current and this current are same, I have a PN junction here. Say silicon, this is also silicon PN junction. I have resistance here RCB, this is also RCB. This is 300K, this is 300K. Then this current and this current are equal. So if I put a mirror here, then that mirror will show same current. You stand in front of the mirror, it tells what are your qualities. Is it not? So if you keep a mirror here, then this side current is same as this side current. That's why it is called current mirror circuit. So in a buffer output is equal to input. In one half this transistor will conduct, in the other half this transistor will conduct. You have two transistors, push-pull emitter follower or buffer, what you have at the output side. So in a buffer output is equal to input, but the current is amplified. So common mode, we said these two terminals are connected. So if these two terminals are connected, V1 is equal to V2 is equal to Vin. Differential mode, if Vin is the potential difference is the difference between these 2 points. So Vin is V1 minus V2. CMRR means common mode rejection ratio. So common mode rejection ratio, differential mode gain by common mode gain. So I will give one example and then explain CMRR. All of you, some of you have very high CMRR. Students at 30X, they have high common mode rejection ratio. Means early in the morning by 6 o'clock or 5, your parent is asking you to get up and you reject them. You say, I don't want to go to the college. So they are giving inputs. They are telling life is so important, your studies are so important, get up. Some input they are giving, you are rejecting because you have very high CMRR. Like that in an op-amp, you are giving some input, it is rejecting. You are giving some input, it is rejecting. So AD by AC, AC is common mode gain is output in common mode by input in common mode. So that Vi comes to the numerator, V0 in the denominator. So under common mode, ideally both the inputs are same, output should be 0. If you have an ideal common mode case, see common mode, here you said the V0 is V1 minus V2 into some gain. So V1 and V2 are equal. If V1 and V2 are equal, then output is A into V1 minus V2. Output is A into V1 minus V2. So if you tie up both the wires, if V1 and V2 are equal, V1 minus V2 is 0, your output is 0. If it is ideal op-amp. But practical op-amp, you have some small voltage. Ideal op-amp output should be 0. So if V0 is 0, CMRR tends to infinity. I said you have infinite CMRR at home, which means input your parent is giving, output from you is 0. So A into something by 0, anything by 0? Anything by 0? Infinity. So in an ideal op-amp, the CMRR is infinity, but in a practical op-amp, the CMRR is some 10 power 6 like that, because you get some small voltage at the output. Then you should know what is slew rate. So what is slew rate? What is slew rate? So your teacher is dictating notes and you write it. Suppose if the teacher is dictating slowly, you write nicely. In the morning, if any dictation is there, it goes wonderfully. Okay? So in the afternoon, you are feeling sleepy and your teacher is dictating very fast, you scribble something.